March 22nd. Put a pin in that date. It's World Water Day.
Right.
And if you're like most people, your brain probably goes to a very specific place when you hear that.
Yep.
You're thinking conservation posters, turning off the tap, maybe a documentary about a drying riverbed.
Which is the standard narrative. It's the scarcity mindset approach.
Exactly. But today, we are not doing the standard narrative. We are taking a hard pivot.
Okay.
We've got a document in front of us from a group called Roots BIM LLC that, frankly, reads less like an environmental plea and more like a technical manifesto.
It's definitely a shift. I mean, they aren't asking you to take shorter showers.
Okay.
They're arguing that freshwater needs to be viewed through an entirely different lens.
What's the lens?
It's called an engineered system.
An engineered system. I have to be honest, when I first read that in the source material, I bristled a little bit. It sounds arrogant, doesn't it? It does sound a bit clinically detached, I'll give you that.
Like we can just control nature with a spreadsheet. But think about the alternative. The alternative is assumptions. We assume the rain will fall where it used to. We assume the pipes we laid 50 years ago are, still holding up.
We assume the reservoir will be full in June.
Exactly. And Roots BIM is arguing that in 2024 and beyond, assumption is a dangerous strategy.
Yeah.
They want to replace it with precision.
And the phrase they use, which is the title of the piece actually, is engineering certainty. That's the hook. Engineering certainty into the future of freshwater.
It's a bold claim. Certainty is a very strong word when you're dealing with something as chaotic as, fluid dynamics and weather patterns.
Right. So that's our mission today. We need to pressure test this idea. Is engineering certainty actually achievable, or is it just high-end consulting speak for better guessing?
Yeah.
Because if they're right, it fundamentally changes how we build our cities.
And if they're wrong, we're just building deeper digital silos. But looking at the tech stack they're proposing, I think they're onto something significant.
Okay, let's get into that stack. Because they aren't talking about better concrete. They're talking about a digital transformation.
Right.
The phrase BIM-enabled water networks comes up a lot. Now, our listeners know BIM building information modeling. We know it's standard in vertical construction.
Sure. You wouldn't build a skyscraper today without a digital twin.
Exactly. But underground, horizontal infrastructure, that feels like the final frontier.
It historically has been. The underground is messy. But the source material argues that we need to apply that same vertical rigor to the horizontal water cycle.
How so?
They use the phrase from catchment to consumption.
Which implies a continuous data loop.
Precisely. Usually water management is fragmented.
Yeah.
You've got hydrologists looking at the catchment, the watershed, the reservoirs. Then you've got civil engineers handling transmission pipes. Then, facilities managers dealing with building inputs.
And they're not talking to each other.
Not in a meaningful, data-driven way. Roots BIM is saying, connect the dots.
So in this engineered certainty model, we aren't just drawing a static map of where the pipes are.
No. A map is static. A map tells you where a pipe was when you put it in the ground. They are talking about BIM-driven water balance and demand modeling.
So it's dynamic.
It's dynamic. It's the difference between a paper map and, say, Waze on your phone.
Okay, I like that distinction. Unpack that.
Well, a paper map assumes the road exists. Waze knows there's a pothole at mile marker 4, traffic is slowing down because of rain, and it reroutes you in real time.
Right.
Modeling with intelligence, as the text puts it, means using computational fluid dynamics, CFD, within that BIM environment to simulate flow, pressure, and velocity before a single drop of water even moves.
So you're simulating friction losses in the pipes. You're simulating pressure gradients across a whole city grid.
Exactly. You are creating a digital twin that behaves exactly like the physical water will behave. And the source makes a massive claim here.
What's that?
They say this allows every drop to be accounted for before it's extracted, stored, or delivered.
See, that's the part that stops me. Accounted for before it's extracted.
Yeah.
That implies a level of predictive capability that feels almost sci-fi. You're saying we can predict the journey of a specific gallon of water before it even leaves the reservoir.
In a fully integrated system, yes. I mean, if you have real-time demand modeling, you know exactly what the industrial park, the residential blocks, and the fire systems are pulling. You don't just open the floodgates and hope for the best.
You release exactly what's needed.
You release exactly what is required to maintain hydraulic integrity.
Do you eliminate the buffer?
You eliminate the buffer of waste. Traditional systems oversupply because they lack data. They push extra water just in case, pressure drops somewhere.
And if you have certainty, you don't need the just in case.
You don't need it.
That brings us to the nuts and bolts section of the deep dive.
Yeah.
Because all this digital simulation is great, but eventually you have to put physical pipes in the ground.
Right.
And the underground environment in a modern city is, well, it's a nightmare.
It's a crowded, chaotic mess. You've got power, fiber, gas, sewage. And Roots BIM specifically focuses on the triad of water systems that have to coexist.
And that triad is
Potable, recycled, and firewater.
potable, recycled, firewater. 3 distinct streams. And obviously rule number 1 is don't cross the streams.
Right.
You do not want the recycled gray water mixing with the drinking water.
That's a given. But the source focuses on clash-free routing. And this goes way beyond just don't let the pipes touch.
Right. When I hear clash detection, I think about avoiding a physical collision like don't run the water pipe through the elevator shaft.
Sure. But there's a temporal aspect to this too.
In what way?
Think about the construction phase. If you are building a complex facility, say a semiconductor plant or a high-rise hospital, you have these 3 massive water systems fighting for space.
Right. In the ceiling or in a trench.
Exactly. And if you find a clash in the field, oh, the fire main is hitting the HVAC duct, everything stops.
You're waiting on an RFI, the crew is standing around, the schedule slips 2 weeks.
And that costs millions. But if you have clash-free routing validated in the model beforehand, you can move to prefabrication. You can build 40-foot sections of the piping rack off-site, truck them in, and lift them into place, knowing for a fact they will fit.
So engineering certainty isn't just about water flow, it's about construction certainty.
It's de-risking the project.
It's financial certainty.
And there's another layer to this triad. The firewater system specifically. The text highlights this as a critical challenge. Why do you think that is?
Well, firewater is unique because you hope you never use it. It just sits there. It sits stagnant.
Right. But when you need it.
You need massive volume and massive pressure instantly.
And that hydraulic shock is a nightmare for engineers. If you haven't modeled that surge, the water hammer effect, you can blow out valves or rupture seals just when you need the system most.
So you're integrating a system that does nothing for 99% of its life with systems like potable water that are flowing 24/7.
And you have to fit them in the same corridor. The source also mentions maintenance access here.
Okay.
This is my personal favorite point because it's so unsexy but so vital.
The jackhammer test.
Exactly. We've all seen it. A city crew tearing up a brand new sidewalk because a valve failed and they physically couldn't reach it.
That just feels like a failure of imagination.
It's a failure of coordination.
Okay.
If you use the BIM model properly, you aren't just placing pipes, you're placing the virtual maintenance guy. You run a simulation. Can a human being actually fit a wrench in this gap?
And if the answer is no,
You move the pipe in the digital twin, not in the dirt 5 years later.
that's that life cycle efficiency they mention.
Yes.
It's treating the building phase as just the starting line, not the finish line.
Which is the only way to view infrastructure.
Yeah.
These systems have to last 50, 70, 100 years. If you don't engineer for the guy holding the wrench in 2040, you've failed.
Okay, so we have the digital brain, we have the physical arteries. Now let's talk about the heart of the issue. Why is Roots BIM pushing this now?
Because the environment we are building in has fundamentally changed.
Resilience.
Resilience, but specific resilience. The source highlights climate variability, and I want to pause on that word, variability.
It's not just global warming.
No. Warming implies a slow, steady trend. Variability implies chaos. It means the highs are higher, the lows are lower, and the historical data is, well, it's garbage.
And engineers love historical data. The 100-year flood, the 50-year drought. We build based on what happened in the past.
Stationarity is dead. That's the industry term. You can no longer assume future rainfall looks anything like past rainfall. So how do you design a water system for a future you can't predict?
You have to simulate the extremes.
You stress test the digital twin? This is where engineering certainty earns its keep. You can take that BIM model of your city's water network and run a day zero drought scenario. What happens if pressure drops by 40%?
Which neighborhoods lose water first? Does the firewater system lose pressure?
Exactly.
Or the inverse?
The flood scenario. Right. If the river crests 3 feet above the levee, where does the water go? Does it infiltrate the sewage lines? Does it backflow into the potable supply?
If you have a dumb system, you find out when people get sick.
But if you have an intelligent modeled system, you can predict the failure points and install backflow preventers before the flood happens.
That's a powerful distinction. Resilience isn't just hoping the wall holds, it's knowing exactly what happens if it doesn't.
And that connects back to the source's quote. The future of water isn't just conservation.
Okay.
It's engineering certainty into every flow. Conservation is behavioral. It's software people making choices. Engineering is hardware. And in a volatile climate, you cannot rely solely on software.
You need hardware that can take a punch.
You do.
I want to push back on one thing, though. I mean, conservation saving water is still crucial, but the source seems to imply that conservation alone is quaint.
Not quaint, just insufficient. Look, you can turn off the tap while brushing your teeth and you save maybe 2 gallons. But if your municipal system has a non-revenue water rate of 20%,
What does that mean?
it means 20% of the water leaks out of the pipes before it ever reaches your house. So your 2 gallons are a rounding error.
20% loss. Is that a real number?
In many older cities, it's higher, 30, sometimes 40%.
That's staggering.
It's water that is treated, pumped, and then just lost to the dirt because of microfractures and bad joints.
And in a drought, that's criminal.
Exactly. So when Roots BIM talks about accounting for every drop, they are declaring war on non-revenue water. If you have that digital precision, if you know the flow rate at point A and point B matches exactly, you can spot a leak the second it starts.
So you're not waiting for a sinkhole to open up on Main Street.
You're seeing a 0.5% pressure deviation on a dashboard and sending a crew to a specific GPS coordinate. That is how you survive scarcity.
You don't just ask people to use less.
You ensure that what you do extract actually gets used.
It changes the definition of efficiency. Efficiency isn't just cheap. Efficiency is survival.
Precisely. In a world of abundance, leakage is a financial nuisance. In a world of scarcity, leakage is an existential threat. Engineering certainty is about closing that gap.
It really reframes the whole smart city conversation. Usually when we hear about smart cities, it's about traffic lights or Wi-Fi kiosks.
Yes.
But this intelligent water is the invisible nervous system.
It is, and it's arguably the most critical. You can live without Wi-Fi kiosks. You cannot live without reliable, clean water.
So we've gone from the digital twin to the construction site to the climate crisis. It's a pretty comprehensive argument Roots BIM is making, but I keep coming back to that core idea, certainty.
It sticks with you.
It does, because usually we accept a certain level of chaos in our infrastructure. We accept that pipes burst. We accept that pressure fluctuates. We accept that stuff happens.
We view it as inevitability.
Yeah.
Entropy happens.
Right. But this manifesto is saying, no, it's not inevitable. It's a design flaw.
And that's the provocative takeaway for me. If the technology exists to predict the journey of every single drop, if we have the CFD, the BIM, the sensors, then ignorance is a choice.
That's a heavy thought. If we can know, then choosing not to know is, well, it's negligence.
I'd agree with that. If a city is losing 30% of its water in 2024, it's not because pipes are hard. It's because they haven't engineered the certainty into the system to stop it.
We have the tools.
We just need the will to deploy them.
So leakage is a choice. Waste is a choice. That's a paradigm shift.
Ideally, it's a paradigm shift that leads to action.
Yeah.
Because as the climate gets weirder, I didn't know it was going to stop being a valid excuse for utility operators.
Look, there you have it. World Water Day isn't just about saving rivers. It's about the hydraulic models and digital twins that keep civilization running.
The invisible machinery.
Roots BIM LLC certainly gave us a lot to chew on. Engineering certainty. I think I'm going to look at my faucet a little differently tonight.
Just remember, there's a massive digital infrastructure behind that flow. Or at least there should be.
There should be. And if there isn't, maybe ask your city council why.
A fair question.
Thanks for diving deep with us today. We'll catch you on the next one.